Hey guys, this is Coach Lowe, and we are going to talk some geometry today. Chapter 2, Section 2, Logic. All right, let's get going. I'm going to give you a few definitions and then we'll work some problems together. So first of all, when we look at logic, we're going to talk about some statements. And when we talk about statements, those are sentences that either are true or false. So they'll have a truth value. So a statement is a sentence that is either true or false. I'm going to go ahead and switch colors here because I know this will be hard to read. So let's see if I can get it going. All right. So either true or false. And usually it's represented with a letter like P, Q, R, lowercase letters, like those three. Negation of a statement. So you can think about negation, and that sounds kind of like negative, and it has the opposite meaning of the statement. So it will be the opposite meaning. And its symbol, or the way it's written, is like a little squiggly in the front of that. So kind of like the congruent sign, the top part of that congruent sign, kind of like that, but it's just one of them. So that means we read that not P, not P. And it could be not P, not Q, not R. That's the way we read it. Okay, compound statement. So think about your English knowledge here. Compound statement are statements where we use and or. So it connects two statements, right? Two statements together, compound statement, connects a couple of ideas together, and we'll use and or to do that. Pen's going crazy again, but I'm ignoring it, as you can tell. Fun times. All right. So let's talk about the two compound statements, the two words that are used, and or. Let's talk about and first. When we deal with and, it's called a conjunction. And both parts of the statements, or both statements, have to be true. All right, for this statement to be true, both parts have to be true. And the symbol for that looks like this, kind of you're going to make a capital A, so you can kind of remember that and A. So if it says P and Q, that's what that means. So let me give you an example. Like if they say, the statement for P, here we go again. It doesn't like green for some reason. I don't like green either. It kind of reminds me of Adair, so let's change colors. All right, so for P, let's say that they say segment AB, this notation, is the proper way to write segment AB. So is the proper way to write segment AB. All right, so that's true, right? So that first part is true. Then let's get the second part. Let's say that Q says meters are, let's do centimeters. Centimeters are metric units. Is that true? Yeah. So centimeters are metric units, and so both of those are true. So P and Q is a true statement. P or Q would also be true because only one has to be true. We'll get back to that in just a second. What if it said P and not Q? P and not Q. So that means AB is a proper way to write a segment, AB, that's true. Not Q means centimeters are not metric units. So now we have true, true, and false. Remember what we said about compound, they have to both be true or it's false. So this is a false statement, even though my writing as floating in the air. That's awesome. All right, let's talk about or statements. These are called disjunction. Only one has to be true. So it's true if one statement is true. So at least one statement is true. That means they can both be true and it's true, but just one has to be true. So let's go back to the P and not Q, and let's change it to or not Q. So now we know that P is true, Q is false, but we don't really care. If one of them's true, then the statement's true. So this is a true statement. So let's go back for just a second. If it's an and, to be true, they both have to be true. That's the only way that one's going to be true. Otherwise, it's going to be false. For an or statement, then the only way that one's going to be false is if they're both false. If they're both true, it's true. If the first one's true, the second one's false, still true. If the first one's false, second one's true, still true. Only one of them has to be true. All right. So let's move on to a truth table. Let's move on and talk about a truth table. So this is a way that we can organize truth values and kind of figure out if something is true or false. So it's a pretty cool table. It's kind of like a puzzle. So let's say that we want to know when not P or Q is true. All right, so what would this look like? Well, the truth values for P could be true and Q could be true. P could be true and Q could be false. P could be false and Q could be true, or they could both be false. Those are all the options, right? So P could be a true statement, Q could be a true statement. P could be a true statement, Q could be a false statement. P could be false, Q could be true, P could be false, and Q could be false. So those are all the possibilities. All right, so if this just said P or Q, these could be all of my options. But it says not P, so I'm going to make another column for the negation of P, and then I'm going to put these guys together. So I'm looking at this column, and I'm just going to write down the opposite of all of these because that's what it said, right? Negation is the opposite. So I have false, false, true, true. All right, so you may be wondering why I'm making these columns, because when I get to this last one, now I only have to target these two columns, and notice that I'm working with or. So if one of them is true, then I know that I'm going to write down true here. All right, so let's look at that. This one is true. I see one true. These are both false, so false. I have two true, so that's true. I only needed one. And I have one true, so that's true. So these are the truth values for not P or Q. That's supposed to be a Q, not a P. Not P or Q. So there's my options. All right, so how do I know how to make this truth table? What pieces need to go in there? Well, first I look at the letters, and I make columns for just the letters, and I write down all the possibilities that they could be. So they could both be true, one, one false, one true, both false. Then I look at the extra pieces, so like the not P, the negation of P, and I make a column for that. Then that leaves me with just one step, putting these two together and an or statement. All right, let's do one more and we'll be finished. So this one's kind of long, and I may not do the whole thing, we'll just kind of see. So P, Q, R, oh wait, let me give you the statement. P or not Q and R. All right, so I've already made the first three columns, and here's why. I made P, Q, and R columns because I see those are the three letters that I'm dealing with. Now, here are the other pieces. We kind of work these inside out, kind of like we do with, like if you have parentheses and you're dealing with order of operations. So I'm going to get a not Q, and I'm just going to keep working with this. Then I'm going to do a not Q and R. So notice I'll put this column and this column together. And then I'll bust out with my last column here. So the first three columns, I just think of the different combinations. And then once I get to the purple columns, then we're talking business here. And we'll have to look back at the other columns. All right. So options. They could all three be true. And I try to kind of stay organized with this. So I'm actually going to do 4 trues on P and then 4 falses, and then we'll kind of deal with the other two. P could be true, Q could be false, and R could be true. P could be true, Q could be true, R could be false. You do not have to do it in this order. P could be true, Q could be false, and R could be false. That takes care of all of the combinations if P is true. Because here's 2 with true on Q and 2 false, 2 true, 2 false. All of those are taken care of. Now I'm going to do the 4 false with P. And I'm kind of going to do the same thing with Q. I'm going to do, would you please stay there? I'm going to do true, false, and then I'll take care of R. So I have true, false, true, false. So P could be false, Q could be true, and R could be true. P could be false, Q could be false, R could be true. So you kind of see the same pattern with the R as well. P could be false, Q could be true, R could be false, and then all 3 of them could be false. All right, let's move to this next column, not Q. So I'm going to the Q column and just negate it. So I have false, true, false, true, false, true, false, and true. Now I'm going to use the Q, not Q, so the negation, not Q and R column. So you can see I've kind of limited myself to these 2 columns. Notice what we're dealing with, it's an and, right? Upside down A, almost, capital A. So one is true, then, they have to both be true or it's false. So I'm looking at these 2 columns. If I see false, I'm writing down false. If I see 2 trues, I'll write down true. So this is pretty good stuff right here. There's only 2 trues on this whole thing. Everything else is false. All right, now let's move to this last column. And now I'm putting P all the way back over here. P and this last column of not Q and R together. So notice this just makes it a little bit nicer. I'm only targeting 2 columns instead of targeting the P column and the not Q and the R. I'm only targeting 2 columns. So now notice my symbol is OR. So if I see 1 true, then it's true. All right, so you can pause the video and try it yourself. True, true. The only way I'm writing false is if I see 2 false statements. There's a false, then a true, then another false, then another false. All right, so that is my logic or truth table to help me figure out this statement and what the truth values are for that statement. All right, guys, video is a little long, but it's good stuff. Assignment is on Google Classroom. I'll talk to you soon. This is Coach Lowe, and I'm out.